And this example asks for the transformations and the vertex. So what transformations do you see? Reflect over x, and what else? Left 4 and down 5. Okay, reflect over x, left 4, down 5. Okay, and then the vertex we said was -4, -5. Left 4, down 5. Okay. And the points for a quadratic are very similar to the points for an absolute value graph, just slightly different. So we've got -2, +4, and then -1, +1, 0, 0, 1, 1, and then 2, 4. And you don't have to memorize these. If you forget the points, you can just take the parent function, which is just y equals x squared, and you can plug -2, -1, 0, 1, and 2 into y equals x squared, and it will just give you these points. Same thing for the absolute value function. If you forget the points, you can take the parent function, y equals the absolute value of x, just the most simple version, and plug in -2 to +2, and it will give you the points to work with. Okay? So how do we take the points and reflect over x? We take the y values and we multiply by a -1. So I'm going to keep the x's the same, change the y's. And how do I shift left 4? Subtract 4 from the x value. So left 4, left 4, left 4. Okay. And how do we shift down 5? Subtract 5 from the y. Okay. So down 5, down 5. And then we have our points to graph. So -6, -9, -5, -6, -4, -5, -3, -6, -2, -9. Okay. And this is an inequality with the graph. So I have to think about whether this graph should be a dotted line or a solid line. Solid. It has an equal to, so it should be a solid line. Good. Okay. And then I have to pick a point to plug in to see where my shading should be. 0, 0. It's a good point to plug in. Nice and easy. So we'll plug the 0 in for the y value. 0 is less than or equal to negative of 0 plus 4 squared minus 5. And you can type this straight in a calculator, but we also want to be able to do it by hand. So which thing do we do first? We got to remember order of operations, so please excuse my dear Aunt Sally. Parentheses first, so 0 plus 4 is 4. Okay, so please excuse. So e is next. Exponents. So 4 squared. And then multiplication and division. I already did that. I said negative times 16 is a negative 16. And then addition, subtraction. So negative 16 minus 5, negative 21. Is it true that 0 is less than a negative number? No, that is false. So 0, 0 is right here. 0, 0 is false. And so where is it true? Inside the parabola. Okay. Say it again? Yeah, that's fine. How do we feel about that one? Good? Okay. So let's turn to the next page. We've got a couple problems on here to do. So vertex, domain, and range. So if we look at example 3, what is the vertex? Okay, that was good. Domain comes from the x or the y values. X. Range comes from the x or the y values. Y, okay. So the domain from the x values, we're going to look on the graph from the left side to the right side. And we can see there's nothing skipped. This graph is continuous, right? If we trace it with our finger, it's continuous. All the values are being used. So I'm going to look at the very left side of the graph. I'm going to look at the very right side of the graph. And what do I see? What number is on the very left side of the graph? Negative infinity is on the very left side. And what number do I see on the very right side of the graph? Positive infinity. And so my domain is from negative infinity all the way to positive infinity. And that part's done. That wasn't too bad. So you'll notice that the domain, just like on the absolute value graphs, those were the V-shaped graphs, the domain is always the same. For the V-shape and the U-shaped graphs, it's always negative infinity to positive infinity. It goes forever to the left, forever to the right. The range, we're looking from the bottom of the graph to the top of the graph. So what number is at the bottom? Negative 6 is at the very bottom. And then what number is at the top? Positive infinity. Okay, so negative 6 is at the bottom. Positive infinity is at the top. Okay, so parenthesis there. And then negative 6, is that a number that is actually on the graph that I can see? Yes. So I put a bracket. Okay. All right. Next section, there's a typo again. Decreasing interval is still x values. So let's fix that typo. Okay, so increasing and decreasing interval, these are both x values. And to make this a little bit easier, I'm going to put my little stick figure guy. So if he starts walking, is he walking uphill or downhill? Downhill. This is decreasing. Okay, so he walks downhill, he gets to the vertex, and then which way is he walking? Uphill. Okay. So we have an x value here, and an x value here, and an x value here. So what is the x value of a left arrow? Negative infinity. Okay, what is an x value of a right arrow? Okay. What is the x value of the vertex? Regular 5, yeah, just 5. And you can see that if you squint really hard and look at this very tiny graph, or by looking at the equation. You could see that from the equation too. Okay, so the increasing interval is what? 5 infinity. And now we have to think about if the 5 should be included. So if I think about the stick figure man standing right here, Is he walking uphill at this moment right here? No. So if he's not walking uphill, should I include the 5? No. So if I'm not including the 5, do I put a bracket or a parenthesis? Parenthesis. Parenthesis means not including it. Okay. So up here, we included the -6 because we could see it on the graph. It's right there. But here, when we look at the stick figure man right here, he's not walking uphill. That's why we're not including it. So he's there. He's just not doing the thing. Okay. Decreasing interval is right here. Decreasing interval. So what are the numbers? -∞, 5. Okay. The 5 right here, at this exact moment when he's standing right there, is he walking downhill? No, he's not. So parenthesis. All right. How are your brains feeling? Good? Okay. Is it easier this time through? A little bit? Okay. You know, the nice thing is we're going to do this like 4 more times. So by the time we like do it again, it's like there's a point where it should be like, ooh, these are the easy points on the test. These are like the gimme questions, you know? Okay. Last, we got to do the end behavior. And who remembers what the end behavior is describing? It starts with the letter A. That's formal. But what is it basically describing? It starts with the letter A. A-R. A-R-R. Arrows. It's just describing the arrows. That's all it's doing, is it's just telling you which way the arrows are going. Are they pointing left? Are they pointing right? Are they pointing up? Are they pointing down? That's all it's doing, but like CJ was starting to say, it's doing it in math notation, which means it's using infinities and negative infinities, and it's saying it as complicated as it can. So left arrow is negative infinity, right arrow is positive infinity, down arrow is negative infinity, up arrow is positive infinity. Right, Blaze? Were you texting me so I knew that? But the message was you texting me to make sure I knew? Okay. All right. So we say, on these, we say as x goes to negative infinity, and this is us saying, look at the left arrow. Look at the left arrow. So if you look at the left arrow, what is it doing? It's going up. So it is going to the left, but it's also going up. So now we're going to say the y is, and if it's going up, what infinity should I put? Positive. Yep. Okay. Now we're going to say, all right, we already looked at the left arrow, so let's look at the right arrow now. If we look at the right arrow, what is the right arrow doing? It's going up. So that's also a positive infinity. So we're saying the left arrow goes up, the right arrow goes up. Okay? Let's try the other one. It would just be the opposite. So we're still going to start with, let's look at the left arrow. So look at the left arrow, and then what should we write? Okay, it's going down, so we're going to say y goes to negative infinity. Okay? And then next, we're going to say, all right, let's look at the right arrow again. And this one does what? It's still going down. And then it's negative, yeah. So the left arrow goes down, the right arrow goes down. So the end behavior is actually exactly the same as the absolute value graphs. If you go back and compare it to your absolute value graph notes, these answers are exactly the same because a V-shaped graph and a U-shaped graph have the same types of arrows. So the combination here is still the same. Okay, so the plan for today is we have a packet